Hi guys, today we're looking at solving trigonometric equations. So let's start with our first example here. This is our first example. So this is a right angle triangle we have here. Okay. So this is our 90 degrees. So here we have x and we have 100 the side, and this is 50, so we have 50 degrees. And then the question may be determine x or find x. Okay, so normally here we can still get this angle here, we can get the size of this angle here. Maybe that can be our first start, or let's try straight to find x first. So you see, if you're looking at x with the given angle here, of which is 50, you're looking at the opposite all over the hypotenuse. So this is what is given. So what is given, if you're standing from angle 50, what is given is an opposite, of which is x, and the hypotenuse, of which is 100. So easily we can just use our sign. We can say sine 50 degrees is equal to opposite, of which is x all over 100, right? So what we can do here, we multiply by 100 both sides. So if we multiply by 100 both sides, what we'll have is 100 sine 50 degrees is equal to x over 100 multiplied by 100. So we're multiplying by 100 both sides, so this is the 100 we're multiplying with. So that therefore we'll have 100 sine 50 degrees is equal to x. So you can just put that one on the calculator. So we have 100 times sine 50 degrees. So this is nothing but it gives us 76.60 degrees equal to x. Okay, suppose we wanted to find another angle as well, that angle. So we know that when we're summing our angles, we're summing this angle with this angle and that one, it should give us 180. So here we can say we have 180 degrees is equal to 50 degrees plus 90 degrees. Maybe we can call this unknown angle here, let's say we call it angle theta. So we say plus theta. So if we're summing all three angles, they must give us 180. So that therefore we can look at 180 degrees minus 50 degrees minus 90 degrees is equal to angle theta. Okay, so we will have 180 minus 50 minus 90, so that is giving us 40. So our angle theta is 40, so we have 40 degrees is equal to our angle theta, of which is this one. So this will be angle 40, and with that one we can easily then find this side here. So you can easily find this side here, but still you can use this angle 50 to find the side, because if you're standing at this angle 50, you see this side would be our adjacent all over hypotenuse. So adjacent all over hypotenuse will be nothing but, let's look at it. So it will be cos 50 degrees is equal to, so let's call maybe this side, let's call it y. Let's say this is our side y. So it will be an adjacent, of which is y, all over hypotenuse, of which is 100. So this is nothing but you multiply by 100 both side, and we multiply by 100 this side. So we'll be left with 100 cos 50 degrees is equal to y, because this 100 will cancel each other. So what we can say, we have 100 on the calculator times cos 50 degrees, but that is nothing but then our side here, so our side here will be 64.28 degrees. Sorry, this is 28 degrees is equal to, sorry, not degrees, but this is our size, so it's just 64.28 is equal to 1. So that is our side here. Okay, so that is how we can work on these problems. Let's try to do our next one. So in our next example here, we also looking at the angle like this, a right angle triangle. So this is something like that, and then okay, so this is our 90 degrees there, and we have x, and we have 25 degrees here, and we have our 7 here. So this is 7. So let's say we want to find all the sides as well. So you see, from angle 25, what is given here is an adjacent of which is 7 and the hypotenuse, so we can easily use cos. Let's try to see if we can use cos. Just to use cos, then we can say we have cos 25 degrees is nothing but x all over, sorry, it's 7 all over x, so we need to find the x. So in this case, to solve for x, we can just say okay, let's try to do it in a slow way so that you understand it. So it would be cos 25 degrees is equal to 7 all over x. Let's say we multiply by x both side. We multiply by x both side, and then we'll have x cos 25 degrees is equal to 7, and you can divide by cos 25 degrees divide by cos 25 degrees, then this one goes off, that therefore we have x is equal to 7 all over cos 25 degrees. Okay, so this is nothing but, if you put it on the calculator, you'll have 7 divided by cos 25 degrees. This is giving us 7.72. So this is giving us 7.72. So this is our x there, 7.72. But you see, from here to look at the simple and forward, so if you got something like cos 25 degrees is equal to 7 all over x, you can just exchange it, so you can just swap these two. That is an easiest way. So the steps that we're doing here will always lead us to that. So you can just say x is equal to 7 all over cos 25 degrees. So this will be always the case, and yeah, this will be always the case when you're trying to solve something, and this is, it comes to fractions like this, you can just swipe them, it will always give you the same thing. Suppose we wanted to find another angle here, we can still do that, because we know that the sum of these three angles shall give us 180. So we can say we have 180 is equal to 25 degrees plus 90 degrees plus the unknown angle, we can call it k, so we can say this is k maybe. Okay, so we can just put it in the calculator. So in our calculator we can say 180 degrees minus 25 degrees minus 90 degrees. So we can say, because now we taking all, so we can say we have 180 degrees minus 25 degrees minus 90 degrees is equal to angle K, of which is 65. So we can then say we have 65 degrees equal to K, of which is our angle here. So this angle here, this angle here is 65 degrees. But you see, now we can easily find this one. So if you're looking at this one here, it's nothing but opposite. Let's say you're looking at opposite all over our adjacent, that should be tan, to find that other side. So we can say we have tan 25 degrees is equal to opposite. So let's call maybe the side here y, our opposite side. So we will say we have y all over 7, right? So we just multiply by 7 both sides. We multiply by 7, this goes off, and then we have 7 tan 25 degrees is equal to our y. Let's put it on the calculator. 7 times tan 25, this is nothing but equal to, so our opposite will be, so here we'll have 3.26 is equal to y. So that will be our side. Hence we have found all the sides, we have found all the angles as well. Let's try to look at the next one. So we still at right angle triangle. So let's try to look at the one that we're not giving. Let's look at this one here. This is our right angle triangle. This is our right angle triangle. So it's like that. Okay, this is our 90, this is our x, so this is our 14, and this is our 9. So we need to find x. Okay, so in this case we're finding the angle, we're not finding the side. So we're trying to find the angle, not the side. Okay, so let's look at what we have. We're looking at the side, the angle x, but what we have, if you're standing from this angle, we have this one as an adjacent and we have this one as an hypotenuse. So this is adjacent and then this is hypotenuse, right? So if you have an adjacent and a hypotenuse, so you can easily use cos. So you have to use cos x is equal to adjacent, of which is 9, all over hypotenuse, of which is 14. Okay, so you need to put that one on the calculator, or what you can do from here, you need to, when you're trying to solve for x, we're trying to solve for x, of which is an angle, we need to find the inverse. We multiply by the inverse of cos. So this will be nothing but x is equal to cos inverse into 9 over 14. Then you can put this one on the calculator to find out what is your x. So we just put in on the calculator. When you're putting the inverse, you need of the inverse of cos, you need to put shift cos, and then automatically you're getting your inverse. So you're saying that shift cos, and then you put in 9 all over 14, you close the bracket, then you get your answer. So the answer that I'm getting here as x is 50. This is 50 degrees. It's 50 degrees because in the calculator I'm getting 49.99, so that is equivalent to 50. So we can say our x is 50. So once we know our x, and then you know you can find this angle here, and then you can find this side here. So using the same method, or the same way that we were using on the previous videos. Okay, So let's try to move to another one. Suppose we have this one here. Suppose we have this one, a right angle triangle. We have something like that, and this is our 90 degrees. This is our x, this is our 10, and this is our 9. Okay, so you see, given x, or let's say this is our y. Let's say we want to find this angle. We can easily find the angle y, because you see, if you're standing at angle y, what is given, because always you're looking at the angle that you're given. Like here we have angle y, so if you're at angle y, what is given is an opposite all over hypotenuse. But same thing if you're looking at angle x, if you are here at angle x, so what is given, this will be now an adjacent all over hypotenuse if you standing at this angle x. But let's try to use to first find the angle y. So that will be opposite all over adjacent, of which we're using our sign then. Sin y is equal to opposite, of which is 9 all over 10. Opposite all over hypotenuse, right? So in this case, we're doing the same thing. To find y will be equal to inverse of sine into 9 over 10. You put that one on the calculator as well. So you have shift sine 9 divided by 10. So we're doing the same thing, shift sine 9 divided by 10. Then we're getting our answer. In this case, our y will be nothing but 64.16. Okay, so to find x, we know that the summation of all angles should give us 180. So we must have 180 is equal to 90 degrees, of which is this angle here, plus 64.16, of which now is our y, and then plus x. Okay, so this is nothing but what we can say here, we have 180 degrees minus 90 degrees minus 64.16 is equal to x. Okay, so we can just put that one on the calculator. So we have minus 90, we have plus 180. So we should be getting that our x is equal to 25.8 0.84, sorry, 25.84 is equal to x. Okay, suppose we're trying to use another way or another method. Let's say if you were finding angle x, because now we know this is angle x. Suppose we tried to use angle x and to use cos. So if you had angle x here, this is your adjacent and this is your hypotenuse, so we can use cos. Let's try that. So cos x is nothing but 9 over 10, and then what we're getting here, we have x is equal to cos inverse into 9 over 10. So shift cos 9 divided by 10, close the bracket. We're getting the same answer. So this is 25 degrees. Sorry, this is 25.84 degrees. So this is the same answer. Either way, you use this method or you use the second method, it is the same thing. So that is how I analyze my right angle triangle. And thank you so much for watching.